And welcome to the Daily Space Weather Show. Happy Independence Day to our American and indeed our international viewers. America, America. All right, so yeah, looking at the last 24 hours of the closest stars activity, that's actually the past just 2.5 hours there. And yeah, we've got some brightening there on the western limb, as that has been the most active location for solar flaring. We've also got a new promising-looking region rising over the eastern limb, the one closer to the equator there. That's looking like it's got some activity in its arsenal. So, yeah, and so there you can see that's the largest flare of the past 24 hours. It was just a low-level M-class event. There have been some CMEs. We'll talk about those as well. One of them is earthly directed, so you'll probably want to stay for that. Here are the past 24 hours from a Solar Dynamics Observatory. So again, two likely spots for large flares at the moment around the western limb, mainly the southwestern. Also around the eastern limb, just south of the equator there as well. Here's a little closer zoom. That is 30 frames per second, 171 angstroms SDO. Now you may see some activity in the south central portion of the closest star, and yeah, there's a CME that's headed toward Earth once again, yet another one. So we'll get to it. You'll get a better view of it here in 304 angstroms. So we saw multiple coronal mass ejection events sort of happen in rapid succession, almost simultaneously. And of course, as always, we'll show you extreme close-ups of the T-mass, the most active sunspot. So that's what's going on the western limb, the southwest. And in your screen upper left there also, those are some magnetically complex sunspots as well, so they are capable of producing large flares. And by the way, don't forget to press the like button if you enjoy the content. Thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing that the channel exists. We figured you wanted to see some more in-depth stuff, right? So, and of course, in honor of Independence Day, let's go with a quote from the national treasure, Mark Twain. Loyalty to the country always, loyalty to the government when it deserves it. What say you? Leave us a comment. Tell us your thoughts on this. Whether you're a U.S. or an international viewer, thanks for tuning in regardless. So, getting through some stats here. The radio flux still at 167 solar flux units. 167 is the radio flux. There it is over the past year as reported by Solon.info/solar. Solon.info/solar. So yeah, that's the past year. Red line's a sunspot number. The black line is the 10.7 centimeter radio flux. A radio signal that comes out of the upper chromosphere and the lower corona. So NASA, that's actually NOAA's forecast there. NOAA's not forecasting any geomagnetic storms at the moment. Maybe they're not watching the channel, but guess what? There is another one on the way. And we do have ESA forecasting some coronal hole high-speed stream. So this is NOAA's forecast. We'll show you ESA's end little spiral here as it's more substantive. There you can see ESA forecasting a coronal hole high-speed stream arriving early in the day on the 7th. July 7th, coronal hole high-speed stream to arrive. And we'll get to CMEs here in a minute. So this is what Earth's magnetic moment from space likely looks like. Our space weather modeling framework model of the Geospace Magnetosphere movie. And yeah, things are calm. So we haven't seen the possible geomagnetic storm that we had our fingers crossed for last night that NOAA forecasted. So sorry, Aurora chasers. It looks like it was pretty much of a dud. That's the past 4 hours of Earth's magnetic moment from space. Here are the last 4 hours of Earth's magnetic moment from the ground. In America, America, America. So yeah, that's what's going on. Ground magnetic perturbations map depicts magnetic flux density at the ground level, and again, it's geomagnetically calm. So KP2 is the current situation. KP2, an average of global geomagnetism. It is not very space weathery at the moment. So no storms coming in. Things are nominal. In fact, the solar wind is quite slow there as measured by ACE. Only 351 kilometers per second. A little bit of a spike in the density there, 8.4 protons per cubic centimeter. Nothing to write home about for sure. Also at Discover, a little bit denser there, about 50% denser at 12 protons per cubic centimeter, but incredibly slow there. Very slow, especially around times of solar maximum, only 350 kilometers per second, so a very slow solar wind, if a little bit more dense than it was yesterday. There are GOES magnetometers. They are in a geosynchronous near equatorial orbit, measuring the magnetic field in the outer portion of the outer Van Allen belt. And we do see some gyrations in their data feed there. But again, no major space weather showed up. Basically, a CME kind of brushed past, and that's about all that's really been going on. So next we'll look at the heliosphere, and Earth is just a couple of hours from snapping into a South Pole-oriented magnetic sector. There you can see that green sector that Earth is about to leave. So a current sheet shall be crossed here in the next couple to few hours. And perhaps by the time you're viewing this video, you will already be in the South Pole-oriented magnetic sector, depicted there in red just to Earth's east. Stereo B is already in the South Pole magnetic sector. Next, our line-of-sight field plot depicting all of the solar magnetism, all in one convenient 4-day movie. Solar B field, the field that goes through the magnet, depicted in blue. Polar fields in red and green for south and north, respectively. And the photosphere magnetism, where sunspots occur, depicted in grayscale. So we'll bring up the last image for that as well. Here we go. There you are. And next, coronal holes. So coronal holes, they show us the solar polar field reversal process as it occurs. And of course, you would expect the most transequatorial coronal holes around times of solar maximum, as the field reversal process is just part of the solar cycle process, just like the rise and fall in sunspot number. At solar minimum, the coronal holes stay fixated at the poles almost entirely. And throughout the cycle, they slowly make their way across the equators and then refixate at the poles at solar minimum. So anyway, there's the current situation. And it looks like it might be a pretty short-lived South Pole magnetic sector here, as you can see there. We can see some more South Pole oriented, or some more North Pole oriented coronal holes here rotating in the eastern limb there. So that's what's going on with that. Next, it's time to show coronal holes from SDO. So there's 211 angstroms, and we've got some coronal holes rotating in here. No proper transequatorial ones, but that one that's rotating in there in the southeast, that is likely to be geo-effective. It is close enough to the equator. It's a pretty significant, pretty well-defined coronal hole, so expect to see some minor changes in the space weather environment from it. Typically marked by, an uptick in solar wind density, and then as the density comes down, the velocity goes back up, usually also accompanied by a different plasma temperature. So anyway, that's what's going on for that. Next, sunspots. Sunspot number has dipped here below 140. We got about 138 sunspots at the moment. A significant dip since yesterday and the day before, where we were around 200 sunspots. So that's what's going on for sunspot number. Here's the likelihood of flares, and that's calculating mainly 3733 and 3729 for the most likely spots for flares. That is just because of their magnetic fields. I don't think it figures in the location in proximity to the limb. So we've also got T-mass. The most active sunspot of the past 24 was 3723, I want to say. No, I think maybe 3730 actually might have been the T-mass. But anyway, that southwestern limb, that is definitely a spot where we could see large flares. But especially, also the eastern limb there, just south of the equator, which would be your screen left. All right, so let's move on to sunspots here from SDO. There is the magnetogram. No major changes here. The changes in sunspot number are largely reflected by sunspots either setting or rising. So that's what's going on as far as sunspots. We'll also show the continuum, of course. So that's what approximately 140 sunspots look like. And we'll move on to energetic particles and solar flares. So the proton flux remains flatlined here, no spikes. But if we keep seeing flaring on that southwestern limb, then the likelihood of solar energetic particle events goes up. And we've got a flare going on as we make the video. Check it out. Very nice. So what do we have? What do we have? Where's the flares? Where's the flares, I say? And it is. Now this is the past just couple of hours here, so should be showing up there. It looks like it's in that western quadrant. Am I missing something? I don't think I'm missing something. All right, so yeah, the largest flare of the past 24 hours is occurring while we create the video today. So that's always a delight. It doesn't happen every time, but we'll take it. Perhaps nothing is left to random chance in the universe. And before we get to our solar system forecast, let's take a quick look through the view of SDO, of that new rising sunspot there in the east. The one closer to the equator is the more interesting looking one based on its previous activity. As you can see, there was a CME popping off there. It looks like it is a little bit more unstable than the one to its south. That said, this area right here remains the most likely place for large solar flares. You'll also see the T-mass. Well, actually, the T-mass is now in your upper left. I was going to say it's your lower right, but it's actually your upper left now. Keep in mind the flare that's happening now will not be depicted in that image because, again, that flare happened while we were creating the video. So here's 131 angstroms also, just to show you the largest flare in this dynamic stellar environment. At least the 24-hour, 30 frames per second video that we put together. As the T-mass changes and we remain flexible for such changes. So before we get to CMEs, we'll briefly talk about your solar system forecast as, oh no, Saturn's in retrograde, which means a thing to somebody. Here's your 1 week solar system forecast as we have a crescent waning moon. New moon is like 2 days away. That's where things will be in a week on July 11th. Next, our star chart, just to show you what's going on above my head. It's from skyandtelescope.org if you want to make your own. Skyandtelescope.org. Jupiter's going to set first, followed by that crescent moon, followed by the sun, then Venus, then Mercury. And let's go to the astronomy photo of the day from apod.nasa.gov. It's a good one. It's a trifid. Yeah, trifid. Why? Because there are emission features in the front of that. So that's a dense molecular cloud there featuring all sorts of different chemicals likely. Those dark features that are kind of splitting that into three. The red would be hydrogen, and the blue portion would be gas illuminated through the ultraviolet emissions, exciting those molecules. So you've got the blue, that's the emission portion of the nebula. The red is the hydrogen. And then those emission features, which look like dark dust lanes, those are more complex molecular clouds. There's the full view. Located in the constellation Sagittarius, the Trifid. It's about 5,000 light years away. Pretty sweet emission nebula there. The Trifid Nebula. And I just wanted to once again thank all of our U.S. viewers, as well as folks from around the world and just take this moment to say, America! Fuck yeah! Coming again to save the motherfucking day, yeah! America! Fuck yeah! Lick my butt and suck on my balls, terrorists, your game is through. 'Cause now you have to answer to America! Fuck yeah! Freedom is the only way out, America! Fuck yeah! What you gonna do when they come for you now? It's a dream that we all share. It's a promise for tomorrow. Fuck yeah! You're welcome for that temporary aside. Now we've moved on to CMEs. And there is another one headed toward Earth. Hopefully my voice is not too shattered to continue on with the video. So yeah, CMEs... Excuse me. CMEs popping off here in the past 24. We'll break it down. So let's move to the LASCO C2 and C3. Now we paused this at 1536 Universal Time for the C2 and 1842 Universal Time for the C3. Reason being, there are multiple events. One of them has a large earthly directed component likely to cause a significant geomagnetic storm. So if we bring this back, you'll see it start to emerge around 1430, mainly out of the west, but then you'll see a second sort of dimmer thing coming out of the east there, and that is the one that is the earthly component. So again, multiple things kind of happening here at the same time. There could be some overlap. Let's take a brief look at what stereo A had to see, and we like to show this because it shows you where stereo A is located. In fact, let me press refresh. There we go. There's stereo A's location for today. That red dot is stereo A. And how did it do? Did it get the frames we're looking for? And no, it does not. So we'll cut to our custom coronagraphs, and you're going to see those events happening. They are kind of around the same time there, but there's actually multiple events. So, and there is some overlap for sure. So, yeah. You'll be able to see it better as we zoom in closer. Here we've dropped the LASCO C3, and we've included the 193 angstrom 60-minute running difference imagery from SDO. And the CME that we're talking about that's earthly directed popped off from this filament down here. Now, a lot of that still stays intact, but it is looking increasingly unstable. So the rest of that could blast off, creating another earthly directed event. But right in here, right in this area here, you'll see that little brightening, and that is an earthly directed coronal mass ejection. So that one's coming pretty much right down the pipe. Hope to see a KP 7.66 from that one. I would expect to see at least a KP 6. So expecting a mild to moderate geomagnetic storm coming on July 7th. July 7th, ESA is forecasting a coronal hole high-speed stream. We're forecasting a coronal mass ejection impact. So that's the scenario. And we're going to cut back to this here in just a minute. First, we'll talk filaments from Cerro Tololo, Chile. So look at that filament, the one that part of it blasted off there, right in the south central part of the solar disk. It remains pretty unstable looking. If you want to name that one after a living person, you better do it quick, because I don't think it's going to be around very long. Here's a grayscale imagery. You can see some huge prominences there also showing up over that eastern limb. So that's that. Let's go to bonus features. As we see that flare popping off in that western quadrant. First bonus feature is charging hazards. And we do have some low energy electrons building up on the outside of satellites there in southern Asia. Southern Asia seeing some surface charging issues. Could cause a little bit of communications breakdowns there from those satellites, possibly reflected in some weather data depending on which ones you're looking at. The GOES electron flux here has dipped once again. That's the past 3 days with the radiographic measurements of GOES 16 and GOES 18. And there's the forecast model. The green boxes represent the forecast, and the yellow diamonds are the observation. Next, the layer where it's measured. Keep in mind those satellites are tens of thousands of miles above where the F layer is located. The F layer is only at about 300 kilometers of altitude, and the GOES 16 and GOES 18 are at about 23,500 miles of altitude, so way above. They use radiography to measure the electron flux, and here's the vibrational frequency, using ground-based systems to verify measurements of the vibrational frequency of the gas in the ionosphere. So that's Australian Government Bureau of Meteorology's ionosonde. And things are looking very nominal right now in the ionosphere. Here's the anomalygram depicting anomaly in megahertz from a 30-day median. And yeah, very nominal, except for one thing. The South Atlantic anomaly remains around the 45-degree west longitude line. So yeah, the South Atlantic anomaly, it's moved hundreds of miles once again, just like when it moved into the Pacific Ocean. We're covering it once again, having moved to the South American coastline. So if you follow that negative 45-degree number along the bottom, just above where it says Commonwealth of, that 45-degree line, that's the 45-degree west longitude line. Follow that to the coast, and you'll see that that is where the South Atlantic anomaly has now relocated itself to. So that's interesting, I'd say. No? Anyway, here's the Global Ionosphere Nowcast, or WHAM, the whole atmosphere model, showing the total electron content and maximum usable frequency. And we got some more imagery for you here from SDO. Let's take a look at these sunspots briefly. So they're looking like they've lost complexity. Despite seeing some flare coming out of them now, I think the likelihood of them flaring in the future is actually going down. So they are beta, gamma, delta class sunspots, just barely. At least the southern one is beta, gamma, delta. The northern one is just barely beta, gamma, delta, but it does count. Now, as far as this one down here, not so magnetically complex. And can we see this new one? Again, that new one is promising. A little bit too early to get a good view of it. We'll close out with this fantastic view of filaments from SDO. If you want to name that filament in the southern hemisphere, join us over on x.com/Smashomash. Just put in the hashtag name that filament, and then tag us in the post at Smashomash, and we'll name that filament. Make it official. Make sure you name it after a living person like your friends, your foes, or even yourself. Once again, happy Independence Day to all of our viewers. Congratulations on realizing the channel exists, and until next time, may that solar wind be at your back.